Hey gang, how's it going? Welcome to session 4 out of our 6-session workshop. Let me share out our notes for today. I have added to the Google Drive the draft for our notes. There we go. So I'm just going to give a quick overview of what we're going to talk about today. I'll do it for a couple minutes to give some people time to grab onto the stream since I just started it. But as usual, I will provide the YouTube link in the notes document. The first couple sessions 1 and 2, I emailed the link directly to everyone, and I did not do that with the third session. And I got an email recently just saying, hey, where's that link? So the links will be in here, but I should have just sent it out too, just to make sure you see it, blast it out your way. So I will do that this time. When I finish the course, I have to wait a couple hours sometimes for Google to, YouTube, well, Google, whatever, to process the video so that I can go annotate it and then send out the link. In fact, I might not send it out until tomorrow sometime so I can make sure to fix any issues with it, cut anything out or whatever. Alright, if we have any chat logs, I'll put them up. Right now we have one student in the chat room right now, so that's cool. People don't like to chat. I think more people are doing this asynchronously, so no biggie there. And we're going to start off with a review of the Session 3 assignment, or homework, if you will. And we're going to have a lot of fun with this. Not only are we going to find the answer to the question that was posed, but we're going to go further than that, and we're going to do some JavaScript deobfuscation. So more on that when we get to it. So I'll be doing some demos, I'll be talking about some stuff, I'll give you some related notes. These related notes, I know that a lot of you are in the CS program at CSUF, and as such, you should probably be familiar with things like what is JavaScript, or for that matter, the HTML DOM, document object, the document object model, document object, or for that matter, just DOM in general. But if you're not, I've included a link to get some more information. And we're going to run into specifically something called string.split. Well, technically just .split in JavaScript. And if you're not familiar with it, I'm actually going to bring this link up during the workshop to explain exactly what's happening so that we can deobfuscate this JavaScript. Okay, after we do the review, and I'm going to go very thorough on the review, we're then going to go over an article. And it occurred to me that myself and some coworkers, we run a website called malwarewolf.com, and I just completely forgot that we do that, I guess. I don't know. But we have an article on there that a buddy of mine, a coworker named Mike, wrote. It's a Wireshark primer on manually carving HTTP objects. So I have no idea why I didn't think of that, but I thought of it last night, and hey, yeah, let's just go over the article. So I read his article when he first posted it, which is back in April of 2014. And I remember giving him some feedback, and I don't even remember what it was. So we're going to look at it. We're going to be objective about that. So the idea here is I've been telling you guys throughout this entire workshop, Google it, Google it, Google it. Well, if you were to Google Wireshark manually carve HTTP objects, you might come across Mike's article on our website. So we want to kind of look at how you want to digest these types of things. So anyways. And then finally, we're going to assign the final homework, the last round. Oh, come on, dude, really? Go away. Sorry, I gotta let the dog out again. Hey, you're not very good at this, are you? Go away. You think I would just not let the dog in the room when I'm doing this? That would be logical, but whatever. All right, so finally, we're gonna do the final. I keep saying finally. Challenge, and yeah, I'll just give you some ideas of what to look forward to. I provided 3 tips on this one, and yeah, use those tips. See, I even say here, make sure to review the tips provided. Okay, so that all being said, we're going to get right into the review of the Session 3 homework, which was Level 5. So what I'm going to do is change my screen here. Hi. We're going to jump in and go to Kali Linux here. There it is. All right, let's unlock this bad boy. Oh, ignore that. Okay, so I gave you guys level 5. Right, so here's the HTML file, here's the PCAP. Let's take a look at the HTML file. And it says here, Miss Jensen, which this is Victoria, by the way, that, you know, since if you go back to level 1, you'll remember her name. And so I said don't focus on the name because it has not been using her last name in the recent levels, so you may be wondering, like, what? Yeah, just don't know, whatever. So she's having issues with her email. So someone's having email issues, is what we know so far. Okay. She decides to check her account balances. So this is a hint here to ensure she still has access to her accounts. Okay. And it says use the level 5 capture to answer the following question. Alright, someone has been directed to a malicious payload. Who's that someone? Well, her, most likely, right? I don't know. How many bytes of data is the malicious payload? So in order to answer this, you'll need to understand some basic things like the difference between a bit and a byte, how many bits are in a byte, and then since you're all programmers, you probably understand how many bytes are in a word and how many words are in a double word, which is very telling by its name, double word. So really what we're looking for is someone who's redirected to somewhere bad. It's the bad place, and we need to find out what was accessed. So with the bad stuff that came down through the wire, how big was it? Now, in general, these are the types of things you need to know. Of course, the primary concern is, well, what was the bad thing and how bad is it, right? Is it malware? Did it infect the machine? Was it just some type of reconnaissance? Was it like a phishing thing? Did she submit credentials? Like all these other things are what you have to think about in the real world. But what we're going to do, we're going to take a look at level 5 PCAP. And I documented the heck out of this bad boy. In fact, you know what? Check this out. I'm going to just speak to my notes, but I do want to show you that I took the time to write this up. So we're looking at the notes right now, level 5 malicious payload, and see, I went paragraph form here. I broke the whole we're going to make the curriculum as we go thing. So I made myself into a liar for session 4. So basically, I give a breakdown here on exactly what I'm going to cover with you, and I don't want to show that bottom part because that gives it away. But anyways, even if you don't follow through the video right now, you can go take a look at that, and it points you in the correct direction. But let's just do it hands-on. So here we go. Here's Kali, open with Wireshark 1.10.2, and just to be sure, we're currently at the most recent version of Wireshark. So, see? So, good deal. So in here, one of the first things that you'll notice is that down at the bottom, let's see, can you see my mouse? Yeah. Down here, look down here. Woo! Packets, 192. There are only 192 packets in this capture. That's not a lot. We've been dealing with, what, 15,000, 20,000? We're dealing with fewer than 200. If I go to Statistics Summary, and I scroll down to the bottom here, check it out, 192 packets. Time between the first and the last packet, less than 120 seconds. How long is that? Basic math, it's less than 2 minutes. Nothing, right? This should be easy. Should be easy. Should be being the key phrase there. And if we go over here to, let's start with endpoints. Hey, look, there's not a whole lot going on here. I like to sort my endpoints by bytes because it shows me the top communicators pretty much. So if you remember from the last round, the Cisco device here, it looks like we still have the same setup, the same environment. Don't make that assumption, by the way, but from what we see thus far, it looks to correlate. So the Cisco we decided was, what, a switch or something, right? And then we have a Hewlett-Packard computer, and then a Dell computer of some sort. And again, these Hewlett and Dell, that may or may not be what we're actually looking at here. What's happening is this right here, this MAC address is coming across the wire 000B CD C2 E491. If you remember what I said, the first 6 bytes, so the first 6 of these guys, right? See those guys? Ooh, excuse me, oh wow. The first 3 bytes, this is a 6 byte value, excuse me. The first 3 bytes, meaning these first 3 segments here, the first 6 hexadecimal characters, represent the vendor. And I don't recall what session I mentioned this, but if you just do something like Mac vendor lookup, you find a couple different sites. Here's one called literally macvendorlookup.com. Wow, I didn't know that existed. Unless we looked at it before and I just forgot. Whatever. So Wireshark just has this built in. That's all that's happening right now. Okay, it's telling us it's a Hewlett-Packard device, but again, we don't really know that. So we have 00ZBCD. 00ZBCD. Oops. There. All right, let's see if this. Oh, hey, look at that. It's actually searching dynamically. Ah, cool. So there, it's telling us it's Hewlett-Packard. All that means is that the MAC address that is assigned, or excuse me, the MAC address this device has, the first 3 bytes of it have been assigned to Hewlett-Packard. What does that mean specifically? Well, that means that when Hewlett-Packard makes their devices, when they assign MAC addresses, they all start with this. Okay, does that mean that it cannot be spoofed? Well, heck no. I mean, check this out. In Kali Linux, you have a tool called MacChanger. And in fact, if I run it with the help option, and then how do you zoom in on this guy? It's just Control plus. Okay. Oops. Hey, it says Control plus. Filthy liar. Well, let's just do this then. All right, take a look at the help for this guy. MacChanger. Options -R is random, I believe, right? Yeah, I usually do that. So random and then an interface name. Where do you get your interface names? Well, you get your internet interface names from ifconfig. So for example, right now we're rocking out on Ethernet 0. So I would simply do this. I would run that. Of course, I can't do that because I am currently using it. Well, lies. I can do that. Apparently, I can do that. Okay. So, and you'll see that the permanent address is this. Well, who's that assigned to? VMware. Well, why is that? Well, it's because we're running in a virtual machine. So the virtual adapter that I'm running has been assigned a VMware-based MAC address. Well, I just ran random. So I randomly generated this MAC address. So who normally uses that one? No one. It's random. It's completely random. So I can keep running this, by the way. Yay. Normally, I thought you had to bring your Ethernet adapter down before you can do this. In fact, are we using Ethernet 0? We are. Well, that's weird. I could have swore you had to bring it down first. I thought you had to run if down 0 first, but I don't want to do that because I'll lose Ethernet connectivity, so let's not do that. So anyways, other features of MacChanger. Whoops. What was it? Dash that? Yeah. You can also do this guy right here. A stands for another, and what it does is it makes a random MAC address, but it sticks to the same vendor MAC, and that's what we're talking about right now. So, for example, you'll notice what it does. Well, wait a minute, I didn't do it. What? Am I doing it right? A, another? Set random vendor MAC of the same kind. Maybe I just don't understand what A does. I always use R. I've always used R. However, I could swear it's supposed to change it to the same vendor. Well, whatever. Alright, so anyways, you can look at that tool, but I'm just explaining the fact that Wireshark, when you have down here, look at the bottom left-hand side, that guy right there, when you have name resolution on, and it says, that's a Hewlett-Packard, that does not mean it's a Hewlett-Packard. It means it's most likely a Hewlett-Packard. That is, if there's no trickery at work here. So, anyways, I think I mentioned that before, but I wanted to go into a little more detail on that, just because when you're doing network forensics, you do not, let me repeat that again, want to do something like, in your report, write a Hewlett-Packard device, blah, 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 because you have no idea what type of device that is. You can run some heuristic scans on it, and you can do stuff with Nmap and have fun and try to do some OS identification, but when it comes to literally identifying the exact type of hardware, good luck with that. There's some advanced research in that realm, but when it comes down to just using a packet capture, what we have in front of us right now, good luck with that. It's probably not going to happen. You can use TCP replay, which is part of, what is that part of? What suite is TCP replay part of? I don't know. I'm blanking on that. Let's find out. Oh, it's part of itself. Okay. Yeah, TCP, it's its own package. All right, well, whatever. You can use a tool called TCP Replay to run back this packet capture over your wire, and then you can run your other heuristic tools against it. But I'm going to digress because we're floating away from our point at this time. All right, anyways, back on track. So we have a top communicator here, right? So this guy's probably doing something. And then we have some Dell stuff here. And then another Dell. There's two Dells in here. All right, let's take a look at, we're on endpoints. Let's go to conversations. And let's sort by total bytes. There we go. And hey, look at this. We have the Hewlett-Packard communicating through the Cisco. And again, this is just an assumption. It says Cisco, so I'm assuming it's a network appliance, a network device of some type. I also make that assumption because the other Dell and, well, both the Dells and the Hewlett-Packard have a lot of communication through, or I should say with, this Cisco device. Does that mean it's a router or a switch? No. Do I think that's what it means? Yeah. Would I put that in a report that's going to go to a court of law? Yes, but I would not put it goes through a Cisco switch. I would put it goes through a device that has a MAC address matching to the Cisco device, and then I would explain also all devices on the network seem to be communicating through this device. Yada, 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 blah, blah. It's obviously the gateway. Whatever it is, it's the gateway. But could that have simply been an ARP-spoofed laptop on the network that just then spoofed the MAC address of a Cisco device and therefore performed man-in-the-middle and tried to fake out as a Cisco device? It sure could. Yeah, I mean, that's how you do man-in-the-middle properly. So we don't know if that's occurring right now. We could technically look at a larger packet capture and look for gratuitous ARP packets to see if someone has poisoned the ARP cache on the network. But again, I will digress on that. By the way, ARP cache poisoning is some awesome stuff. You know what? I'm going to make a note right now. I'm making a note right now for next time to talk about ARP cache poisoning. Ignore that. ARP cache poisoning and how it's detected in a packet capture, because that is vitally important for things like what we're just talking about. Was it going through the actual gateway, or was it going through someone else? Okay. Anyways, I'll digress on that point. So we still have our communicators, and if I go over here to IP and I sort by bytes, you see that we have, remember last time, it looks like the same lab environment, 172.28.155, and if you remember the other one that we were looking at was the .50. Remember these were the ones that had some stuff going on last time? Well, we see that other stuff and bytes, values. So far, I'm not really getting anything. Right? Because if you remember, you always want to refer back to the task at hand. And our task at hand is directed to a malicious payload. All right. Now, for a malicious payload is looking at who's communicating and how many bytes they've transferred. At this point, is that going to help with identifying a malicious payload? No, not at all. However, we do want a byte value for the payload. So just in general, it's related. It's showing size of stuff, but no, not really. It's not telling us anything. So remember, we only have 192 packets. I mean, check this out. I can literally scroll through this. It's very rare that you can analyze an entire packet capture by literally just scrolling through the freaking thing. But that's what we're going to do right now. So if you look here, protocol, right? You have UDP, protocol, DHCP, someone's trying to get on the network, looks like. Syslog stuff, DHCP, DNS requests for pop.where.secureserver.net. Some POP3 stuff. What's in this POP3? Oh, authentication failure. So check it out. And again, I just randomly started going through the darn thing. This is in TCP Stream 0. See right here? I highlighted it there, top left-hand side. In TCP Stream 0, we see this right here. Someone is trying to log on to production. Well, I'm assuming that means production. You know, you have various stages of servers. You have your development, you have staging, and production. Typically, production is something that is denoted in a host name or at least in some type of diagram to show that this is the server that will be externally accessible or at least is in the running for other people to access. You want your staging and development servers secure and protected because they usually don't have the same security updates and, well, their development boxes. They may have some APIs that people can hook into that you don't want people touching. Okay, anyways. And then we have PHX3. This is just an assumption that it means Phoenix 3. Why? What Phoenix 3? What? I don't know. So far, maybe this is just a production server in Phoenix, and they have at least 3 of them. Is that true? Probably not. I just made that up. SecureServer.net. Now, I can go run a whois on this to find out what it is, but I'm not going to do that right now. But you can do a whois on it. You can go check out domain tools and get some more information on the domain. But I'm going to digress on the research part of it because we're more focused on forensically analyzing specifically what's in the PCAP. And I don't care about the server. I want to see what they tried to do with it. They tried to provide a user to it, right? What type of server is this? Well, remember, it's POP3. See, we see right here? POP3. And by the way, POP3, the only reason we're seeing right here, if you can see the mouse, let me circle it a little bit right there. The only reason you can see POP3 right here is because Wireshark is looking at the port number, and Wireshark says, I think that's POP3. So what would that mean? Well, it means it's port 110. So I just happen to know the port for POP3. You need to know ports, by the way. Let's verify this. Let's do something here. Let's have some fun. So we have TCP stream 0, right? And it says here TCP. By the way, we see POP traffic right here. So it's actually decoding the protocol as POP. See? POP. Stands for Post Office Protocol, by the way. It's used for receiving email from certain types of servers. Those servers being, well, POP servers. The current version of POP is POP3. Anyways. Right now in our Wireshark view, we don't have a column with the ports. Let's fix that. If I go up to Edit and then down to Preferences, again, Edit, Preferences, I get this guy here, and under User Layout, we have columns. And look, these are the columns that we're seeing. Number, this is the packet number, time, source address, and destination address. And then we have the deciphered protocol, along with packet length and information. Well, in between these guys, I want to also have port numbers. So how do I do that? Well, I click down here, Add, and it just says the title is New Column, and the type is a number. What? Let's fix that. I'm going to change this. Ooh, look at this. What's the first one? I want the source port. There it is. Source port. By the way, there's a very, very big difference between source port and source port resolved. Ah, what's that about? Now, in fact, I always use SRC port. I just noticed now source port. I don't like that one. I'm going to use these. The difference between resolved and unresolved is very simple. Unresolved will give you the port number regardless of what Wireshark thinks it is. The source port resolved, Wireshark uses its built-in lookup table and says, oh, that's POP. But source port unresolved will say 110. Now, just because something travels over a port number, for example 110, does that mean that it's post office protocol? Heck no. In fact, if I know that a company allows traffic over 110 through their firewall, I will set up my backdoor on that port. If I set my backdoor to use port 55602, that's not a port that I'm familiar with. I just made that up. 55602. Is that going to be let through the firewall? I doubt it. If it is let through the firewall, is that going to trigger some type of anomalous detection? I would hope so. But what about 110? The firewall just sees 110, right? So the firewall is going to say, okay, go ahead. So anyways, let's do source port unresolved, and then let's even call it source port. So I just renamed the title. You can just click in there and then rename it. I just named it SRC_port. And what is it? Source port unresolved. And I'm going to move this right there. So now my view, I should have source address and then source port unresolved. I don't want Wireshark to make an assumption. In general, it's very handy for it to do that, but I don't want to do it right now. I just want the number. So we're going to add another one, and this is going to be destination port unresolved. So dest port unresolved, and then we will call this dest port. Oh, technically, yeah, usual naming goes by that. So right after the address, I want the destination port unresolved. Okay, so what I've added is source port unresolved, and destination port unresolved. And I've added them just following the addresses. And I click apply and hit OK. And wait a minute. Did that not take? Do over. Oh, I'm sorry. Over here under displayed, you have to tell them to display. I could have swore they were already checked, but whatever. Okay, so I checked displayed, and now, there we go. We have source and source port. Unresolved, right? So over here, Wireshark says protocol. That's POP. If you look over here, what's the port? 110. Is that why Wireshark is saying POP? Well, Wireshark goes a little more advanced than just looking at the source port. It also will try to decode the traffic based on the source port, and it's able to do that. So Wireshark is pretty darn sure this is POP. But still, even if it's POP, it might be going over a different port. So why would it be going over a different port? I don't know. But it can happen. When I say it can happen, I mean it does all the freaking time. So now we have a different view here. We have source, source port, destination, destination port. Cool. That's going to push our info over a little bit to the side, but that's just fine with me. So let's go back. You can click on any of these because they're all part of TCP Stream 0. But let's do a follow stream again. So what are they doing? Looks like they're hitting a POP3 mail server, and they're trying to use this username, Mrs. Death Merchant. Okay. So if you remember, as we've been going through this, the guy uses Death Merchant, and Miss Jensen, Victoria, uses Mrs. Death Merchant. That's cute. Their family likes to stick to death, I guess. Whatever. And then they try to provide a password. Why are we seeing a username and a password? Well, because POP is not being secured here. It's just clear text. So the password they use is 123 change me bang. That's usually referred to as bang in programming, but exclamation point. Is that a strong password? Gosh, no. But anyways. And then we get an error. Error, authorization failed. Uh-oh. So she's trying to get her email, and she's failing. By the way, if you are taking notes in an investigation, as you should be, let's see, where are we at here? Let's make a new page. What are we on, level 5? Level 5 stuff. Oh, wait, where'd I go? Nope. Yeah. I just put this all in my notes. TCP Stream 0. Bam. Alright, and then I have other stuff down here. So I know one password she uses, and if I'm doing forensic analysis and I might need to use a password to log into something, which by the way, you rarely would do that in a real forensic analysis or investigation. You would not log into people's stuff. But I'm just saying you have the password that she's used for one. The other thing is that let's just say that she goes by this name and she uses this password, and you know that because you found it forensicating. You did some forensification, right? And all of a sudden you see connectivity with a different username to some different server, and this is not part of what you thought was going to be in your investigation. So for example, you see something that's slightly related, but I don't know. And it's like an IRC channel connectivity, and the username or nickname, as an IRC uses, is completely different. However, you see them attempt to use the exact same password. That might give you a heads up that it is that person. Now, of course, if you're targeting one person's host and capturing traffic, well, then you know that it is that person. Well, you know it's whoever's logged into that host and using it at the given time, unless it's a workstation used by multiple people. But anyways, let's say you're just on a switched environment, you turn on promiscuous mode, and you start sniffing away at traffic. By the way, promiscuous mode allows you to pick up all traffic, even traffic not intended for you, on a switched environment. So that's very important to promiscuous mode. Yeah, I'll just toss this link here in our notes. And you know what? I will talk about promiscuous mode. And the last session, I'm going to do more of like a... yeah, I'm going to do some technical stuff in the last one, just in general, just setting up how you can analyze traffic and get through stuff. But anyways, I'll digress on that. Go away. All right, so what was I talking about? Oh, so if you're in promiscuous mode on a network, and let's just say maybe you see IRC connectivity with that username, you might think, well, maybe it's the same user. So you didn't think to look for that, but you noticed that little guy in there. In fact, you can run this through Network Miner as a keyword, or you can just grep the packet capture for that, or you can use Wireshark and search for the string for that, and you might find other sites or other servers or other services for which Miss Death Merchant uses the same, Mrs. Death Merchant, excuse me, uses the same username, and then you have other places to look. Okay, so anyways, she couldn't get her email. Cool. Now, that's all of TCP Stream 0. Let's clear that out. And again, remember, we're only working with 192, but there's not a lot of stuff here, right? So I'm scrolling down. I see my POP traffic. Here's the user. Here's the password. Here's the error response, right? And then here, by the way, this is the standard teardown of a TCP session. Fin ACK, ACK, fin ACK, ACK. Well, that's not exactly standard. Maybe there were 2 sessions or something. I don't know. But it's a breakdown of a session in TCP. So the TCP handshake that I talked about, I think in session 1, I might have made that up. The SYN, SYN-ACK, and ACK is how a TCP session is started. Well, how is it torn down properly? Well, using a fin ACK, and so we can look that up. I'll put a note to include fin ACK stuff in my notes. In fact, if you've noticed, at the end of all of my notes, I have fin ACK at the bottom. It's a little. I'm just being cute. It's like a TCP teardown. I'm so funny. All right. Anyways, moving on. So what's next? Well, we have another standard query for Debian.Lake Missoula group. Okay. I don't know what Lake Missoula is. We could find out if we wanted to. Anyways, no such name. Doesn't exist. Oh, okay. Also, we see an ARP request here. So the Cisco device, which, by the way, lends additional credibility to it being our gateway since it's sending out ARP requests, is saying, hey, who's that guy right there? And this guy's replying, says, oh, yeah, that IP? Oh, that's me. And it provides its physical address. That's just how ARP works. More on that in the session, what are we doing here? Session 5, we'll talk about ARP stuff. So, okay. And hey, is this more POP stuff? What's this? Follow the stream. Is this the same stream? Nope, we have another stream here. TCP stream equals 1. Look it. It's the same thing? Yeah, prod, yep, tries it again. She tries a second time. All right, so in our notes, we could put, where are they? Down here. Oops, we'll learn to spell. Same activity seen in stream 1. Now, in notes, is it good to say something like same activity? I don't know. We didn't diff it. We didn't run a diff on this, so I don't know for a fact that it's exactly the same. Like maybe one of these numbers are different. I don't know. I highly doubt it, though. But in your notes, you'd want to put the whole thing in there just to be safe. Or really, as long as you have the filter in there and you've already hashed your packet capture so that it can't be farted around with, then you'll probably be all right. Okay, so let's clear that guy out. So we have a second attempt to get into email. And then down here, we have some SNMP, Simple Network Management Protocol. And if we right-click and go to follow UDP stream, we see that we have an SNMP string of public. That's horrible. That should be changed. So that's just a string for device management. It's kind of like a password typically. We'll get into that. Actually, no, we're not going to touch SNMP. So if you ever take a larger network, like I guess network design course, and you're talking about switch management and things of that nature, you'll get into SNMP and how you configure devices. But anyways, we see we have a lot of it. In fact, it created this filter for us, this very annoying looking filter. You know what? Let's go through this filter. What's going on here? We're looking for this IP address and this IP address and that UDP port and that UDP port and the traffic. So basically, the 2 IPs communicating from that port to that port is really what's happening here. And you'll notice that port 161 . If I search for port 161, this is a pretty good site, speedguide.net. Be very careful of what you find on here. Well, those two statements did not go hand in hand now, did they? It's a very good site. Be very careful for what you find on here. Let me rephrase this. This site has a wealth of information, but fact check anything you find on here. How about that? Okay. It says here SNMP. It's used for SNMP. Well, that makes sense so far, since we have SNMP going over that port. See? Test port 161. Right there. Okay. You go away and clear that out. So then what do we have? Well, then we have a query for pop.gmail.com. And then look, we have more POP3 traffic. What's this? Oh, we're trying to get POP3 traffic from Google now. Google is not a silly billy. Google uses authentication. It uses secure sockets layers. So what we're seeing when we do a follow stream on the Google Mail is we're seeing a public certificate transferred. This is information from the public certificate right here, along with this. Well, this is all. They are signed by Equifax Secure Authority, so that's their CA, their certificate authority. And Google has its own CA, so it's and then GeoTrust. Here's the certificate revocation list is right there. Let's see, should I talk about that? No, that's really outside of network forensics for the most part. Well, at least our direct view of what we're doing. Yeah, I'm not going to get into certs and certificate revocation lists and all that stuff. If you want to look it up, knock yourself out. But basically what we're looking at here is TCP stream 2, and since we have so few streams, I'll just, in fact, you know what, I like this more. Let me change my notes. Get rid of that. And we put this up here, so we start out the right way. We say, hey, TCP stream 0. Off traffic. Failed off. And then TCP stream 1. Same thing as seen in stream 0. Ooh, look at that. And then down here, what is stream 2? Pop traffic to Google, or actually, excuse me, to Gmail. Uses SSL. Darn. So Gmail is encrypted. It didn't used to always be encrypted, by the way. It was kind of weird, but now it is by default, which is the way it should have always been. Anyways, it uses, we have SSL and TLS in play here. So you'll notice it's doing client key exchanges. So in other words, what's happening here is it is exchanging certificates, and this is all encrypted. So if I tried, like I just did, if we look at the stream, we look at what transferred, this right here, yeah, good luck with all that. If you don't have a certificate to apply, you are not going to get any love, and we don't. So, okay, that's why SSL is important, because if we have someone capturing traffic on the network, they're just going to get a bunch of gobbledygook, which is exactly what we have here. So what do we have so far? We know that this user tried to auth to whatever mail server this is, and again, we can go look it up, but tried to auth to this guy right here. All right. In fact, you know what? Let's just do it. I don't know if this is real, so let's find out. Know who has information for that? All right, that's easy. Let's just do well, you know what? This looks like a shared. Yeah, we're probably gonna get nothing on this. So who owns SecureServer.net? Yeah, it's a private registration through GoDaddy. Client, well, that's just, yeah, domain administrator, GoDaddy. Yeah, Wild West Domains LLC is the registrar. It's not private, excuse me. So that tells us absolutely nothing on who really runs the freaking thing. Well, we can look up more information, but I'll digress because that goes outside of our direct care. Moving on is what I'm trying to say. Here we go. So moving on. Hey, look at this. We have a standard query, DNS query for Paimia? P-A-I-M-I-A. I don't know what that stands for. So who owns that? I keep opening that window. Go away. I don't know if that's actually a real site. Oh, look. It is, yeah. It's currently registered through GoDaddy, and it looks to be a private registration because we're not. Oh, I lied again. Oh, no. Yeah. Domains by proxy. So this one is a private registration, meaning we really don't know who has it registered. And we can go to sites like Domain Tools. And PAIMIA, was that it? I already forgot. PAIMIA.com. Yeah, that's it. .com. You can do a lookup via Domain Tools. You can also use a site that I like quite a bit called RobText. There's so many sites. PAIMI. Oh, look at that. You remember my last input. Andy, I guess. Okay, so Domain Tools. What do you say here? Yeah, it's not helping. It's not helping. That's not helping. All right, it has used 56 changes on 33. It's used 33 unique IPs over the last 7 years and changed 56 times. 2 registrars with 1 drop over the history of the site. So this is really not telling us a whole lot, except for the fact that it is not a brand new site. And the screenshot history, which is a really cool feature, Domain Tools has a cached picture of the site. That's what it looked like at one point. All right, so it's registered, but at this time, when this was taken in, what month is this? May. I had to think, what's the 5th month? Numbers are hard. In May 31st of this year, it was basically not in use. Well, at least the root page was not in use. Who knows what it was actually hosting elsewhere. So, okay. So we have a DNS query to that, and then look at this. Our first HTTP traffic. Unencrypted traffic. Right-click, follow stream. Here's the fun part. Here's where we have some fun. We have a GET request for this file. This that is the correct URL encoding method to designate an ampersand. You'll notice that they drop the, that's funny, the ampersand to designate ampersand. Huh, I didn't think of that. They drop it here, but this looks fairly odd to me. And then there's our host. Our user agent says that we're using Firefox 13 on Windows. And we have an HTTP OK. Okay, running on Cloudflare. Standard type of web server here. Data is chunked. And then we have data that comes back. But look, where's our data? It's not there. Another thing is, look down here. The entire conversation is 3,132 bytes in length. And if I go down here to the response, I see that 2,462 bytes. Does that look like 2,462 bytes to you? Sure doesn't. So where is it? What's going on here? We can also change this. Check this fail out. Another bug, I think, in Wireshark. When I go right here, this is supposed to be just the request, 670 bytes, but it's showing me both. Why? Well, maybe this is breaking it. I actually don't know. This would be another bug report. So it's kind of odd that we found 2 potential bugs in Wireshark, because see here, same freaking thing. It's showing me the exact same thing. This should just be showing me the request though. So something's wrong there. I have to assume that's partially due to this or other characteristics that we're not seeing right now, but yeah, it could also be an anti-analysis technique that's in place. So, okay, anyways, so I'm confused here. We have a GET for this file, but where's the freaking file? Well, look down here. We have a GET, and then down here, we have a 200 OK text HTML, right? So I say, well, what the heck? So I follow stream again. It's the same thing. What? And this is on TCP stream 4. So 3, let me skip 3 for some whatever reason. 4, GET request, is it 200 OK? Can't find. Can't find stuff? What's going on here? You go away. All right, so here's the trick. What's happening right now is the fact that this is a compressed entity body. What does that mean? Well, it means it's compressed. That's really what it means. In fact, if we look down here, content encoding is gzip, so compressed with standard zip algorithm. So here's the trick. If you look, and you have to have this 200 OK selected right here. But if you look down at the very bottom of Wireshark, take a look down here. We're currently viewing the frame data down here. And then I can view the reassembled TCP, which is what we've already been able to see. No, it's not. It's actually the compressed payload. That's what we want, actually. The dechunked entity body. What do we really care about? Oh, look at this guy, the uncompressed entity body. Oh. An HTTP 200 OK is the response comes back. What type of response? What's the response? To get it, you have to click here on uncompressed entity body. Click. Oh, look at that. What's this? What's going on there? What? It's JavaScript. Oh. So you'll see right here, line-based text data is what this shows up as. And even if I do a follow TCP, it does the same thing. It won't show me what I really want. What? This is the malicious payload right here. And it says down here 3,113 bytes. That is the answer. This is the malicious content. It's compressed, and it might even be using some anti-analysis technique. I have not torn apart the packet capture to really find out what's going on, but if you look here, there's additional script after that big long string. So we have JavaScript in here. Oh, that's what happened. All right. So how do I get this out? Well, there's a couple ways to do it. Over here, I mean, this is the script right here, part of the script, and then you have, yeah, it's missing some of that down there. But so here's the fun part. I apply as filter selected. Data text lines. Here's my 200 OK. Right? Can I follow it? No, you can't follow it. Go away. So let's go back to that data-text-lines. Okay. Wait, apply that. Daddy. So how can I get this? I want this stuff. Well, one way to get it is just to go down here and just to freaking copy it. Copy. Bytes. Hex stream. There's a hex. Ooh. And if you remember, in fact, I wonder if that will actually show the compressed or not. Let's find out. Oh. Yep. So, hey, look at this. What's going on here? All right. Now, what I did, to review that real quick, line-based text data. Okay, this is the decrypted text. See down here when we're looking at it under uncompressed. Now I right-clicked on this, and then I chose. I have no idea what I chose. What the heck? Oh, I did copy, bytes, hex stream. Here's another way to do it. Probably even easier. Export selected packet bytes. That's exactly what I want to do, right? So I'm going to call this level 5 dot what? I'm just going to call it bin or blob or whatever, because at this point we really don't know what it is, right? So normally people just consider it binary. If it's just binary data, I don't know what it is right now. So we're going to save that. Let's go see if that worked well for us. All right, bin file. Open it with LeafPad. Oh, hey. Decodes it for me. That's much easier. Hey, there we go. So there you go. That's all you have to do. That's the easy way to do it. Well, excuse me. That's not the easy way to do it. That's the hard way to do it. That's what I meant to say. Some of you were saying, easy way. What, dude? All right. So that's it. The answer is 3,113. Well, let's do some more stuff. All right. So we can convert. And by the way that I did it was just copying the hex stream, and then I went into Python and I just made it a string and then did the .decode hex. And we also got this, and we can just copy this out and put it in a text document. So there's a couple different ways to get it from Wireshark. So that seems like kind of a pain in the patoot. So we clear it all out, and again, how did we find it? Well, really how we found it is we just started going through the freaking PCAP. Scroll down. We're like, well, that's encrypted data there. Oh, look, what's this? Right-click, follow stream. There's a 200 OK on here. Well, where's the data? Oh, it's compressed. So whenever you see that, most pages, by the way, but web pages are compressed. They're decompressed on the fly by the browser. I'm not sure if you're all aware of that. But we come down here to the gets, and you can even do stuff like http.request.method and sort like that. You can do equals post. There's no posts in this document, so you can do a get, and there's the get we want right there. So what you can also do is http. And by the way, when you type in these things, it gives you a little cheat sheet right here. Check that out. Yeah. So same thing, we can go to expression and type HTTP and then drop that down, and then oops, whoa, went too far. There you go. And then you have these guys right here. So let's do http.response.code equals 200. Oh, look at that. This would be a really good filter to use just in general. And I'll put this somewhere in our notes. These notes, of course, will go out tomorrow. Or, well, excuse me, today or probably tomorrow, actually, given my time frame. But notes will go out tomorrow. Okay. So I'm looking for response code 200. What's a response code 200? I think I already covered response codes. But if I didn't, response code definitions. Response codes come back from a server. A 200 OK means that your get, head, post, or trace, man, I have not seen this in years. Anyways, your HTTP request was all right. So you're going to get data back. A get will grab an entity and pull it down. A head will just show you the header for that to see what type of data it is. And then a post is usually a user providing information to the server. You're posting data to the server. So, all right, so we did a get and we got a 200 OK, right? Status code. What are some other status codes you want to be aware of when it comes to forensic analysis? Well, another one you want to be aware of is the 300 level. The 300 level is redirection. See this? I like this article. What is? Oh, this is the RFC itself. Well, that's fairly handy. The RFC, or request for comments, is one of the most important things you're going to ever come across when it comes to network analysis or network forensic analysis. Typically because whenever a protocol is designed, it is released as a request for comments, an RFC, and then when it's ratified, it goes out and it becomes an official RFC. And that means that if you're not sure exactly how a protocol works, go look up its RFC. So let me give you an example. Right now we're looking at HTTP response codes. Let's just type in HTTP RFC. And we find RFC number 2616, Hypertext Transfer Protocol version 1.1, which is what we still use today. And I click on this. This is directly from the Network Working Group. This obsoletes 2068. Now, we're looking at HTTP 1.1, so I have to assume that this article is for HTTP 1.0. Oops, I'm wrong. Never mind. I figured that would be the case. That is not the case. It's just one that got replaced. Okay. So who worked on it? These people. Whee! Those people worked on it. When was it released? A long time ago. June 1999. That was the updated version of it, of course. Obsoleted by all these new ones. So let's find the most. What? Google gave us an old one. All right. Updated by these ones. So the most recent one's this guy. For authentication. Okay. Well, whatever. What's this guy? Caching. See? Specific. These are specific. I wouldn't say this is obsoleted by then because these are target specific. Yeah, this looks to be the most recent one. Semantics and content. You know what? They might have actually broken it out into multiple RFCs. Wow, that's a long freaking RFC. Holy moly. Yeah, we're just going to stick with 2616. This is the one we used when I was in school. So, anyways, you can look how long it is. Oh, my God, this is so long. quit scrolling, Ryan. Okay, I'll digress. This is part of the RFC for actual response codes. So it's not just a Wikipedia site saying, oh, hey, these are what they are. This is the literal RFC that the entire internet acknowledges. So when something deviates from an RFC, it's usually referred to as RFC non-compliant, meaning that someone is breaking the rules and they need to stop it. So we talked about de facto and de jure. When something is following an RFC, that's de jure. That means like this is set in stone, man. You need to do it this way. If I make my server such that an error 301 means that your computer's date is set to my birthday, it's supposed to mean it's moved permanently. So I am non-RFC compliant. I'm breaking the rules. What am I doing? That would be a really funny thing, by the way, to have a server respond back on just my birthday. But anyways. So redirection, 301, move permanently. And 302, hey, I found it somewhere else. These both mean you're being redirected, so heads up. In these cases, you're going to want to look at the refer. The refer will typically be in here. So it'll show the refer in here if we don't have the refer, because too easy to have a refer for the exact example I'm showing you. But anyways, go back to, what was that? 200, apply. And look at this. I can even make this permanent. How do I make this permanent? Save. Just call it 200 OK. And there it is. So let's just, remember last time I made GET requests and there's POST requests? Now we have 200 OK. I don't like this name. Can I change his name? Oh man. 200 OK. Delete you? Oh, to delete those you have to go to Preferences and then delete your saved queries. So now I just have 2 of them because I wanted a space there. I'm not going to go through that. We have a lot more content to cover here. So, okay, so again, uncompressed entity body, and there's our JavaScript. And you can even do one of these. Scroll up and just look at it in here if you want. All right, so we have JavaScript. Okay. All right. So what do we do with that? Well, we have it named binary right now. It's not really a binary. It's JavaScript. But we have JavaScript. We have the answer. It's 3,113 bytes. But what we want to do, aside from close some of these darn windows I opened up, is we want to go a little further. We want to talk about some other ways we could have found that information. So watch this. You ready for this? I'm going to show you. Yeah, close those up. What's this? Yeah, you go away. I'm going to show you a really easy way to find it. Some of you are probably wondering, why didn't you just do that? Well, because I wanted to show you the harder way of doing it and then show you how you can just rely on some of the simpler methods. So let's say I have no idea what's in here, but there's a malicious payload that came down. Payload tells me that there's actually data that came down, so check it out. I go to File, Export Objects, HTTP. Oh, hey, look. There it is. Packet number 151, and you'll see that is our 200 OK right there. There's our host, the content type, there's our size. That's the answer right there. 3,113. You would have been done. And we see the file name, and we can do a save as. And let's just call it level, let's see, method2.bin for binary data, unknown binary data, and just take a look at it. And hey, look at that. There's our script. Done. That's it. Right? That's pretty easy that way. Does this always work? Does it always work to go, and I'll do it again, File, Export Objects, HTTP. Does that always work? No. Does it work often? Yep. Here's another way to do this. We're going to switch screens now. Hi there. We're going to go to Windows XP. Oh, what? Password. I'm pretty sure it's password. Ah. Oh, it rebooted on me. Okay, that's cool. Yeah, I'm aware of that. Go away. Well. Oh, that's because my silly butt gave it access to the internet last time. It didn't turn it off. Haha, well, it's going to snapshot that sucker. This is a malware machine. You don't want malware machines to be reaching out to the internet normally. So, Yeah, luckily there's nothing running on it. Let's just turn it off for now. Okay, level 5 PCAP. Remember that program called Network Miner? Let's open it up. Oh, yeah, that's a bad link. This is a good link. We open up Network Miner and we take level 5 PCAP and drop it on there. And check it out. Files. There's 6 files that it found. What kind of files did it find? Well, it found 4 public certificates, and they're going to be from Google. Remember when we tried to hit, or the user tried to hit Gmail? Yeah, I know you were updated. You shouldn't have been. Go away. Well, we have the pop Gmail, oh, just copies of those guys. Yeah, so we have some public certs, whatever. We have a fave icon, which is the icon that you see in the browser on the left-hand side. Let me open a browser. Oh, this malware machine only has Internet Explorer. So go to home screen. See this guy right here? You go away. This guy right there, just to the left of the URL, that's the fave icon. Whenever you first hit a site, it often transfers you the fave icon. So we hit this site, it gave us its fave icon. In fact, I think we can just open. Oh, what? Open folder. Here's the fave icon. No, not that one. Wait, what? Oh, no, that's odd. vnd.microsoft? Vendor.microsoft? Well, whatever. Fave icon file. Oh, no editor. What kind of file is this? Oh, it's an actual. Okay, so ignore that. All right, but look right here. We have an HTML file. How big is it? 3,113 bytes. Oh, open it. What is it? To help protect you, Internet stops stuff from happening. Oh. Remember when I said that if you use Network Miner, that it automatically decompresses and basically extracts everything to your hard drive? Well, take a look. Right now, in my Network Miner folder, I have a folder called Assembled Files. And then under the IP address, I have HTTP. These are all folder names. And then this, and then this. So if I just take this part, and I cut that out, and I open up Explorer, and I put that in there, you see that, oh, look, it's on my computer twice. For some reason, actually. So it's just sitting on my computer. So if you have malware in these things, be very careful. Now, I tried to open the JavaScript in a browser, which would have run, which is partly why I disabled the network connection right now. But Internet says, or Internet Explorer says, I don't know, something weird just happened. You shouldn't do that. So, but look what's happening. If I view the source, bam, there's our script. So that file that we just extracted using Network Miner, that's our guy. So again, how you do that? You just drag it to Network Miner, the PCAP, go to Files, and then here, the safer thing to do is to go Open Folder, and there's your file. So you can just relabel this level5.javascript. And then I can open it with, what do I want to open it with? I want to open it with just Notepad. And there you go. There's my JavaScript. And I can scroll all the way over. Alright, so we did it a couple different ways in Wireshark, and we also used Network Miner. So now what I want to do is I want to take that extra step. Okay, we have JavaScript. We want to deobfuscate this JavaScript. Now, we have it called level5.bin. We know it's JavaScript, though, so I'm going to rename it JavaScript. I'm going to open it in LeafPad. Alright, so I have this. Alright, I want to make this look pretty. It's too bad we don't have a really good resource for how to deobfuscate JavaScript. Meaning, obfuscation, referring to the fact that I can't tell exactly what it does by looking at it because it's obfuscated. It's hiding its intent, and for that matter, it's also really difficult just to read it, like visually. Okay, oh, you know what? That's right. We do have a really good resource. I actually made a video on this a month and 3 days ago. I posted this. So we have a site that we run, some buddies of mine from work, called malwarewolf.com. And right here, I started off a deobfuscating JavaScript and shellcode workshop, if you will, or a little two-part series. And so on here I go by 8 bits of brain. And I talk about tools to use, Windows tools, Linux tools, oh, online tools. And then here's my video. So it's a 27-minute video that I did, and you guys can go check this out. I have it in the document in our notes. So I'm not going to just play the video because that'd be boring as heck, but I'm just going to use some of the techniques that I used in the video. What I'm going to do is I'm going to try to stick to only using Kali, since that's what I asked you all to download. In the video, I use another distribution that has a bunch of other handy tools. Check the video out. It's pretty awesome. I like it quite a bit. But we're just going to use Kali to do this. So we have this JavaScript, and we can't read it. Well, you can download tools to make this look pretty, but right now we're just going to use an online tool. It's called jsbeautifier.org. See? jsbeautifier.org. Oh, thanks, Patrick. Patrick just put in chat, said, hey, stupid, you're not sharing out your screen. There we go. There we go. All right, so jsbeautifier.org. Let me go back. This is, sorry. We just have our script here. That's all I'm looking at, right? So it's hard to read. I don't know what's going on here. So I take this, I copy it, I go to JSBeautifier, and I paste it. And then you have some settings and some options at the top right-hand side of this website. Be very careful with what you put on a website, by the way. If you're dropping code onto a website and that code was specifically targeted to your company, you might be tipping off the person that is trying to attack you that you're analyzing his or her code. So heads up on that. But anyway, so here on JSBeautifier, we see that it's set for braces on their own line. Yeah, I like that. That's the setting I made. So I choose that, and then right here, Beautify JavaScript. Click. Ooh, now I have a much better view of this JavaScript. Check it out. So I'm going to take this JavaScript, and I'm going to replace it. Oh, look at that. Now I can see what's happening here. Now, in this file, we have JavaScript, but you'll notice that we have a script tag. It begins with a script tag, and it ends with a script tag. So I don't want those tags. I just want the raw JavaScript. So I'm going to delete those tags, like literally just delete them. Delete, delete, and delete, delete, and save my file. In fact, oddly enough, the entire JavaScript fits on the screen that you're looking at right now. Perfect. Now there are multiple ways to find out what the heck this thing is doing. If you watch my video, you'll see that there are many, many tools, many ways to look into it, yada, yada, yada. What we're going to do is we're just going to use one very easy-to-use tool. The first thing we're going to do is we're just going to look through this manually. The reason we're going to look through this manually is because I know that a bunch of you are CS students, and therefore you should be familiar with JavaScript. If you're not familiar with JavaScript, this one, yeah, that one, and that one. There's a good Wikipedia article on just what JavaScript is. And if you're not familiar with w3schools.com, you need to be, because it's freaking awesome. This site shows you all kinds of cool stuff about different web-based development. And so this is a JavaScript tutorial, and it gives you a cool sandbox interface. Like it says, click date to display the current date and time. Click. That's done using JavaScript. The fun part, though, is try it for yourself. I click on that, and look, it shows me the code. Submit. I just changed it. Ooh, isn't that cool? All right. So if you don't have your own environment set up to do analysis, you can use this. It's very handy to use. But anyways, so check this site out for JavaScript stuff in general. JavaScript, I'll tell you right now, JavaScript is a browser-side scripting language. Now, by browser-side, I mean that the code runs in the user's browser. It does not run on the server. That's very important. That's very, very important, because anything that runs on the user's side can be edited and just rerun by the user. So you have to be very careful on what you include in JavaScript. I've seen a couple different websites. When I say a couple different, I mean like hundreds of thousands that are out there that are hundreds, well, no, millions probably. Actually, it's a ridiculous number, most likely. I don't know. That use JavaScript to do user input sanitization, which, by the way, happens to be one of the articles I have on that site if you want to check that out. If you're into web development, go look at that. But basically, if we have a user who is not allowed to put a certain character into a web form or it's going to crash the server, if I do that user input checking only on the user side, the user can just use like a proxy, a man-in-the-middle type of proxy, or they can just save the page and edit the freaking code and then completely crash your server because they'll just get around your dumb little JavaScript. It's all done in the browser. Okay, anyways. So JavaScript is very dangerous because a user might get something like what we're looking at and have no idea what's happening, and just it can happen in the background. In fact, what we're looking at is a background-based attack. This user will never know that this attack is occurring. How do I know that? Well, because last night I decoded this and I found out what it's doing right now. So, in network forensics, you need to know JavaScript. Excuse me. And since many of you are CS students, you also need to know JavaScript. So let's take a quick look at this. The script starts off. Let's see. Can I make this bigger? Oh, there you go. That's big. And let's make it full screen. Yeah, there we go. I actually like the way that it uses the coloring here. So we're just going to look at this in JS Beautifier. But anyways, the first thing we do is we set the variable v to that value there. Okay? What's that value? Well, I have no idea. The next thing it tries to do, and literally tries to do, is it sets up a try-catch statement block. A try-catch statement, what that means is it's going to, the language, this is, by the way, something that most languages have. If you're not familiar with try-catch statements, just go Google that. You'll find out detailed information on your language of preference. Python uses it, C uses it, C++, blah, blah, blah. So a try-catch means try to do something, and if you fail, the catch usually is for error handling. So what we're going to try is we're going to try to take this variable and we're going to try to do that to it. What is that? It just means increment. This is JavaScript, but it's also used in many of the languages. So we're going to try to increment this value, or this variable. Well, what is that variable? Does that variable exist? No. The only variable we have so far is v. So if we try to increment that, it's going to fail. So what's going to happen? It's going to catch the failure. Ah, so what's happening right now? This is part of the obfuscation. This is trying to throw off manual analysis by people who don't know what a try-catch statement is, I guess. It's also trying to throw off, probably more importantly, automated analysis. So automated analysis may fail to catch it properly, whatever. So what we're doing here is just saying fail and go over here. Okay. The next thing we're going to try something again. So in the catch block, this is the entire catch block right here, we have another try catch. We're going to try to take v and add it to v. Now we do have a v. It's a string. We're going to add a string to itself, and then we're going to do that. Well, what the heck's that? We're going to pass it to a function that, like, wait, no, what? We're going to call it, what is this? Well, who cares? It's going to fail. This is nothing. So it's going to go to the next catch statement. Again, this is just to throw off like automated or manual analysis. So now we're going to do some real things. We're going to set the variable m to math with a capital M. Math is an object that's in JavaScript that does mathematical computations. Math.count, math.blah blah, math.whatever. So we are instantiating the object math into the variable m. So for now, we don't need to know exactly what math is. Just know that this math object that's just part of JavaScript is going to be referenced by the variable m, a lowercase letter m. Okay. We're also going to make the variable ev into eval. Okay. This is a key indicator that something malicious is about to happen, by the way. Eval is, and if you watch my video, when the eval statement, code goes here, eval means evaluate this code further. So it means process this JavaScript that I have in this, that's being passed to eval. So why are we setting ev to eval? Well, the first thing that I noticed is down at the bottom. See that right there? I just highlighted it. It says evs. ev is actually eval. So we're telling this sucker, hey, evaluate s. What's s? Well, we don't know that yet. Moving on. So this try catch is going to fail, which means it's going to go here, and these are going to happen. And then we're outside of this try catch block, but we're still in this one. So now we're going to assign a variable called in. And for in, we're going to give this long string here. You'll notice it's chunked by ampersands, and then either 3-digit or I saw some 2-digit numbers in here. Yeah, or 2-digit numbers. And let's see, can we go to the end of this line? Yes, we can. You'll notice that it's actually not just a string, it's doing a dot split, and it's splitting it on the ampersands. Oh, so what does that do? Well, some of you are programmers, so you should be familiar with this. A string dot split and JavaScript will take a string and it will split it with a provided delimiter and turn it into an array. So it says here, let me scroll down a little bit. I'm pretty sure there's a good example, or not. This isn't the one that I found earlier. I don't like this one. Oh, and I have notes in your whatchamacallit already on this. Here we go. Isn't this the same article? It is. Am I just blind? I think I'm blind. Hold on. Oh, I thought we had a good example. I don't like these examples. These are boring. Well, anyways, so you have a long string like this one. How are you doing today? And then we do a split on that string. What that does is it's going to make an array. And here we're making res, an array. The array is going to have the individual values from this guy. So what are the values going to be? Well, they're going to be this. If you don't provide, by the way, a delimiter, the split is going to use the white space for the delimiter. So it's going to split this up into individual values. This will be index 0, index 1, 2, 3, 4 in our array. So I could have swore I saw an example with days of the week. I must have seen that on some other website. Well, whatever. All right. So we're going to take this string and we're going to make it an array. So really, what is in? Is it a string? No, it's an array. With what? It's an array that has all these values here. It splits by these, so these are tossed out. So it's just going to have these numbers in there in the array. Okay. And now we have h, which is going to equal 2. Okay. And then we have s, which is being created here as an empty string. Okay. And then here's where m comes into play. Remember up here where we made the math object and we instantiated that into m? If m means, does m exist? Basically, that's all it's asking. Does it exist? Yeah. We make it up here. So it exists. So this is going to run. And this right here is the primary deobfuscation loop. What this is going to do is it's going to run a for loop. And again, you're programmers, so you probably know this, but if you don't, what this is saying is it's going to start off with I equals 0. And this says, do I run or not? Well, we're going to run if I minus 611 is not equal to 0. That's what this means, right? And then what do we do after every time the loop runs? Well, we're going to increment I. I equals 1 plus I. They could have technically just done that, but they didn't. They did it this way. So whatever. So we're going to increment I. Down here, inside each iteration of the loop, we're going to say k equals I. So for the first value of I is 0, k equals 0. All right, but you'll notice we don't use k at all. So why is this here? Just to throw people off. That's all it is. There's no purpose to this. So, okay, or maybe there's a purpose. I don't know what it is. Maybe the person writing it just really likes the letter K. I don't know. But it's not used, so don't care. All right, now we have the part that's going to cause us a little bit of headache. We have if window document. It looks like that is what we really wanted. So if window.document. Now here's the fun part. JavaScript running in a browser, it's going to have the document object model object called window. And it's also going to have one called document. So window.document refers to the currently open document. That's all it is. So if window.document, if you have any code whatsoever running in a browser, window.document is going to exist because the page you're looking at is window.document. So this might as well just say if 1 equals 1, because if you're running this in a browser, which is the key term, in a browser, that's always going to be true. So we're going to take S now, and again, this is for every iteration of our loop. We're going to take S, and we're going to do some stuff to it. How many times are we going to do that? Well, let's evaluate this stuff over here. the first time we run, it's going to be 0, right? So you can go like this. 0 minus 611 is not equal to 0. Is that true? Sure is. It's not equal to 0. It's equal to negative 611. So it's going to run, and then it's going to increment I. I is going to be 1. Then you take 1 minus 611. Is that going to not be 0? Yeah. Oops. Oh, there. Yep. That's true. It's going to run. How long is it going to run? It's going to run until I equals 611. So, which means it's going to run all the way up to when I equals 610. But it also runs when I equals 0, since that's where it starts. So how many times is it going to run? How many times? It's going to run 611 times. So what are we doing 611 times? Well, that's nothing, so nothing's happening there. But here's what we're really doing. We're building the string S. Remember, it's created here as an empty string, so we're going to append to the string. String from char code. What? What is string from char code? What's going on there? Well, if you don't know what something is, you look it up. Now, this actually just does some conversion for Unicode characters. Convert a Unicode number into a character. Oh, okay. So the Unicode number 65 will be converted to A. In this case, right? 65. So if you run that, so what are we doing here then? Well, we're going to create a bunch of letters, basically. Using what? N is our array. The index value of n is going to be I. So for the first iteration of our loop, we're going to take n0, which is the first number in n, 25. Right? So we can even replace this with 25 if we wanted. 25 minus 020 plus I modulus h. Modulus means remainder. If you're, again, programming, you should know this. You better know this. Modulus means you take the number, you do the division, but your answer that you care about is going to be the remainder. Excuse me. So, what the heck did I just have here? Okay, cool. So we're going to take 20, and order of operations, this is going to run first. Right? So what's this going to be? A little math here. We'll do this quickly. Let's just say I is 100. I'm going to do this part first. What is 100 modulus h? Well, h is always going to be 2. H is not touched in this loop. So h is always 2. So what is 100 divided by 2? What is the remainder of 100 divided by 2? Well, it's 0. Right? 100 divided by 2 is 50. How many are left over? 0. So we're going to take 20 plus 0, which is 20. So we're going to take this number, which is 25, and we're going to subtract 20. And then we're going to convert that to a character. Anyways, it goes on in this fashion over and over and over and over and over. Right? So what if it was 101? What is 101 modulus 2? Well, 101 divided by 2 is 50. What's the remainder? 1. So 20 plus 1, 21. All right, what if this is 102? What's the remainder? 0. It's just 20. 103. The remainder is 1. It's 21. You'll see here it's actually just adding 20 or 21. That's all it's doing. It just makes it look more complicated. So once we've built this S variable out, which is going to be a whole bunch of characters, the next thing we have here is another try block. We're going to try to decrement, meaning subtract 1, from that variable. Does that variable exist? You see it up here? I don't see it up here. It's going to fail. So what's going to happen? It's going to evaluate S, meaning it's going to tell the JavaScript engine, hey, go run S. So what is this? I don't know, but let's find out. Well, I do know, but we're pretending like we don't know. So we have our code here, and let's open a new window. There's a cool tool. Actually, it's pretty cool, so I'll say that. There's a tool called SpiderMonkey. It's installed by default in Kali, which is very handy. It's made by the Mozilla Project, which are the same people who make Mozilla, the browser, Firefox, you know. And it's the JavaScript shell, a simple interpreter program that uses the JavaScript API. Oh, cool. What does this mean? It means we could run JavaScript outside of a web browser. Okay, I'm not going to go into a whole bunch of detail on this, but basically we have JavaScript we can run from the command line. That's what we're doing here. So let's cd to workshop, session 4, and we have level 5 JavaScript. Here's how you use it. You say JavaScript, -f is input file, and I want level 5 dot JavaScript. And we get an error. I'm trying to run this code, and the error comes back. It says window is not defined. Well, why is that? Well, window is not defined because we hit this guy. If window document. Let's actually make this a little more readable. There we go. We're hitting this right here. If you remember, I said the window document is something that the browser itself is going to provide to JavaScript. Well, we're not in a browser. We're just running the framework of JavaScript in a command line, and it does not know what window.document is. But I'll tell you what it does know, or I'll tell you what we know. We know that this is useless. We always want this freaking thing to run. So we have a couple options here. We can just take the freaking thing out. If I just take this out like this and just bring this guy over like that, it does the same freaking thing. Or what I can do is I can just say, you know what, forget the window document. If 1 equals 1, when does 1 not equal 1? It always equals 1, right? So I can just edit the freaking thing. In my deobfuscation video, I mentioned that you have to be very careful of editing certain JavaScript if you ever see the term arguments.callee used anywhere in the JavaScript. But for this one, we don't have that problem. So I can just do that, or I can just remove the whole thing. I like to leave the if in. Why not? I'm just going to leave it in. In fact, I think what I mentioned last time is that you should never delete something. So you should do this. All right. So what's going to happen? Well, JavaScript, SpiderMonkey, I should say, is going to take this input file and it's going to try to evaluate S. Now, do I want SpiderMonkey to literally evaluate this? No, I don't. What do I want it to do? I want to print it. SpiderMonkey, this is not a standard JavaScript thing, by the way. SpiderMonkey has a function called print, which will just print a value. Now, instead of evaluating it and running the dang thing, I just want to see what it is, right? I could have skipped this whole little thing. Like, the fact that I went through this is just because you guys are CS students. If you weren't, I would have just said, hey, here's how we find out what the result is. But the idea is you also want to know, like, you're going to come across a lot of obfuscated stuff in network traffic, and you're going to need to know what that is. That's part of the forensic analysis. What happened, right? So, anyways, we're just going to print it out. So we have replaced two things. You said, forget that thing. Oh, by the way, a comment in JavaScript is that. X. And then, so I said, don't evaluate it, but just print it. I like the tabs on this. There we go. I like that more. Okay, so we just replaced that. And again, you could just delete that. Don't even need it there. But I'm just going to leave it because we had an if statement, so I'm just going to leave it. I don't know, I'm just being weird, whatever. And then we're not going to evaluate it. We're going to print it. Right? I save this, and I run it again. Hey, look at that. It just printed out what the S string is going to be. So what I want to do is I want to redirect this to a file. Level 5 dot, well, it looks like more script. It's more JavaScript. So let's just call it stage 2 dot JavaScript. And then I can cat that. And there it is. That looks really ugly, though. Let's not look at it there. Let's look at it in LeafPad. Hey, look at that. More JavaScript. Now, it's ugly, right? I don't like this. So let's go back to jsbeautifier.org. I zoomed in pretty far here, didn't I? Paste that in. Beautify it. Ooh, much easier to read. See the difference there? And we take this and we replace it. Bam! All right, what is this code doing? It's pretty easy to see what it does at this point. Zoom back in. All right, the code starts off and it says if document.getElements by tag name body array item 0, if that exists. Here's what this is doing. Remember, document is an object that the browser will provide. Get element by tag name. If you provide a tag name to an element in HTML, you can access it via JavaScript. It's just part of how JavaScript works. It's one of the more basic things on how to grab HTML properties. Body is a default one, though. So the tag name body belongs to the body of a web page. It's pretty simple. So if the body exists at all, really, we're just, element 0, who cares, whatever. Does body exist? Yep. If so, run iframer. What's iframer? It's right here. It's a function. Okay. What if it doesn't exist? Well, then do this. All right, what are both of these doing? The exact same thing. This document.write and this right there are both going to append the code, either that code for that one or this code for this one, into the document. For example, let's say that this guy right here, let's say iframer does not run, but rather this runs, document.write. All right, what is this? Open that up. Let's go to make a new file here. All right, what are we going to write? It's going to write document.write iframe. Oh, look, we're making an iframe. Let me give it a source. That's all we're doing. This is all we're doing right here. It's just standard HTML. Iframe source is this. What's that? Clickzip.org? Uh-oh. I don't know. The frame is going to be a 10 by 10 frame, but the visibility is hidden. Oh. Position is absolute at left 0, top 0, which means it's going to be the top left-hand side of the browser window, 10 by 10 pixels, but it's hidden, so you won't even know it's there. And what is it doing? It's loading this. All right, that's what that version is doing. That's what this guy does. Well, what if, let me go back to this guy, what if we get iframer to work? What's iframer do? Well, we make a variable f, which is document create element iframe. Oh, look at that. We're just making an iframe in JavaScript as opposed to doing it in HTML. Pretty freaking simple. So, okay, we're going to set the attribute. So we have an object, which is an iframe. So f is now an iframe. Set attribute source. Oh, look, it's the same freaking source. We're going to set visibility, hidden. Absolute positioning. Top left-hand side of the screen, 10 by 10 pixels. It's doing the exact same thing that we did up here with this iframe. But then it's doing document.getElement by tag, blah, blah, body. It's going to access the body of the document that we're looking at, and it's going to run append child, which means add code to the page. What child? The iframe that we just made. So this makes an iframe using JavaScript, and this makes an iframe using standard old HTML. So we're going to be redirected here. Network forensics. We just found out by deobfuscating this JavaScript where the heck this guy goes. You can do this JavaScript deobfuscation of the JavaScript and other tools. And again, watch that 28-minute video I have. It shows you all kinds of fun tools to do this with. Let's see if this is live or active right now. In fact, hold on a second. Yeah, why not? Hey, this may be active malware, so please be aware of the fact that this is multiple years old, and I just don't care whatsoever if Kali accesses a bad resource. But for you personally, do not access this. Please don't access this. Aww, the domain no longer exists. Well, that's boring. All right, what was the domain? Clickzip.org. Not found. Oh, that's boring. Well, at one point, clickzip.org must have existed, so subtext, clickzip.org. There it is. Click on that. For that matter, Domain Tools gives you some pretty decent information. The oldest DNS info involved in the analysis. No. Records. No. Just finding org stuff. No, it's just finding. Okay, it's not finding. Domain tools for the win in that case. Domain tools will tell us when it was registered. Who is history? 241 records have been archived since August of this year. 2 changes to 2 IPs over 2 years. Alright, so at one point it existed, it no longer exists. Who is records not available? Well, whatever. What was this most likely? Well, it's called clickzip.org, so I would assume, and this is just 100% assumption, I have no idea what this actually was. But if you look here, clickzip.org feed frames user ID 56 frames 4. This could just have been some type of ad generator, ad revenue generator. It could have been one of those things where it gives, you get free clicks without someone even knowing they're clicking on something to generate revenue for you. But I doubt that particularly because the user ID of 56 doesn't seem like they have many users. So it could have just been malware that's pulled down out of the iframe and that runs automatically. For that matter, heck, it could have been additional JavaScript that came down. I don't know. But so far, so good. In these cases, when you're doing network analysis, you would then want to find out how many users have hit clickzip.org. So if you have logging in your environment, you would want to look back for X number of weeks, months, years, whatever your organization's policy is, and find out who hit it. And if they did, then you need to pull some packet captures if you have those, or just evaluate additional traffic to see what happened. So there you go. Alright, so we covered multiple ways to find that data in multiple tools, and we also covered how to deobfuscate JavaScript. JavaScript deobfuscation is an art. Watch the video, there's all kinds of other cool tools on there. You're going to run into that a lot. So let's take a look now at our notes. What else do we have there? Oh, the article review. Okay, so this is the article. Oops, I can't type. Dash in there. The article that one of my buddies wrote from work. Let me pull it up and share the screen out. We're just going to look at the article and see if it's any good. Wireshark primer, manually carve HTTP objects. Alright, so for the background, he talks about capture filters and display filters, and then he mentions hex editors. And if you remember for this class, let me zoom in a little bit. For this class, I provided the installer for HXD, which is a good one. At work, we really like O&O editor, but it's paid to get the full feature functionality and to not have a 30-day limited trial, I believe, is actually what it is. You have to pay for it, so just use HXD or an equivalent to any hex editor, really. So he talks about using Wireshark and to find a named TCP stream, finding some data. So he gives information on how to search a PCAP. We've covered that. We've used that almost every single session. In fact, I think this is the first session where we didn't do a Control F. And then follow the stream, and then he shows you how to follow a stream. We've covered that multiple times. And then talks about how you'll see the headers and things of that nature, and gives a screenshot. So we've seen this. And then he's talking about carving data. So check it out. We've done this in a hex editor. He's going to talk about how to do it directly from, well, he's just going to show a different way to do it, basically. So he's going to show that removing data before the file, let's see, HTTP file, entry bytes, and he talks about file signature, cool. Remove the data that isn't our file. We did this last week when we basically, we did this exact same thing last week then. Okay, and then carriage return. He gives it some heads up on hex values for carriage returns and new lines. Carriage return is 0D, new line is 0A. That's fairly important. It's good to know. Extracting chunked objects. Now here's the fun part. This is something we have not talked about yet. Sometimes you're going to have what's called a chunked object, and a chunked object looks like this. When you look at, can I click on it? Yeah, there you go. When you look at the file and follow TCP stream, if you see this value right here, 5A8. This is, by the way, a RAR file. See right there? That's the file signature. The file signature is very telling with a RAR file. It's, hey, it's a RAR. It's a type of compression utility, RAR. It's used often on the internet. So 5.8a is the size of the individual chunk. Oh, let me go back here. There we go. So, okay, cool. He says that 5.8a is the size of the chunk. That's hexadecimal representation, obviously. So the easiest way to remove chunk data is with wildcard replace, available in some hex editors. You simply find all data between these guys. Then you simply remove those values and the hexadecimal number. So what is OD and OA? Well, remember up here, he says it's carriage return new line. So why are we trying to remove the data between carriage and new line? Well, because this. Well, no, that's not. This is the chunk size at the end, 0. There's no chunk size in this picture. Let me let's get rid of that one. I'll just close that one. Where does he show chunk? Well, I guess this is the only one of the chunks. Okay, this chunk size is 5.8a. Chunking, which I should probably describe, means that you're going to have different portions of the file come down separately, and now they'll be reassembled on your side, which is great. But Wireshark is going to show you the size of each chunk. So if I were to scroll down, I don't think he gave this example file, but if you were to scroll down here, after 5A8 number of bytes, you would see another chunk value, meaning how many bytes are in the next chunk. See, by the way, transfer encoding chunked. I'm saying chunk too much. It's kind of funny. So the next value that you see, now how do you strip them so that you just have the data? He's showing you a way to kind of programmatically do it. His way is he's saying, okay, look, you're going to have a value, and then you're going to have data, and then you're going to have another value, which is the next size of the next chunk, and then data, and then another value, and then data. So every chunk is going to start with the size of the chunk, which is going to be kind of annoying. So he's saying, just do this. If you go in a hex editor and you do a search or find replace, I guess, for ODOA, and remember ODOA is carriage return new line. Your data is only going to have a carriage return new line for when it's going to give you the chunk size, and then it's going to have another carriage return new line for the actual data that's in that chunk. So he's saying in order just to get rid of that value, you take new line, value, new line, you run that throughout the entire file, and you take it out, and you have at that point successfully removed these little, well, see, he doesn't give a screenshot directly of it, so, but remove directly the chunk values, and all you're going to have left is the data that's individually in the chunks themselves. So this would be a lot easier. Is there a sample file here? No, there isn't. No. I'll leave that to you guys to grab a file. It's chunked. Then he also gives an example of extracting objects from HTTP 206s. 206 response means the content is partial. So I'm going to leave this, by the way, as part of the homework. I'd like you guys to go find a packet capture that has HTTP 206s in them. I don't believe that we give one here. I don't think he gives one. Follow this and see what you get. So I'm going to go make a note right now to add that to the official homework for, what is this? It's coming up, session 5. And then we'll cover what it looks like. I'll find a PCAP and go from there. And by the way, if you're wondering, like, what do you mean find a PCAP? Well, like, watch. Let me just search for PCAP. Yeah, that's no good. Example packet captures. Hey, here you go. Sample captures from wireshark.org. Oh, cool. Pcapper.net. That's one. Other sources of capture. Oh, look at that. Woo! Look at all those. Oh man, look at that. So here, I'll give you this. You can easily find packet captures. Go try to find a packet capture with a 206 response, or just Google like PCAP 206 HTTP or something like that. Gnawing on fragmented payloads. Oh look, someone else did an article on the same thing. Cool. All right, so you can go take a look at this one too. I'll get both links in the notes when I upload them. I'll probably upload the notes tomorrow. But yeah, just go through his thing and see if you get the idea of what he's talking about. I want to see if you guys can follow this, so if anyone has the time to do it, great. Otherwise, we'll just cover this bad boy next session. All right, HTTP 206 responses. This is something you're going to run into in network forensics, and if you've never seen it before, you're going to be like, wait, what? You'll see what I mean when you go through this. So he does a pretty good job explaining that part. So just read that. Mike hooked us up with an article. I'll have the other article name in the class notes for you. Okay, so again, the class notes, I'll probably have those sometime tomorrow, Saturday, yeah. And what else do we have here? And I'm looking at our notes. We had that, and then the homework. Okay, so in the homework that you have level 6, and I will upload it as soon as I end this video. The level 6, I'll just give you the HTML file and the PCAP, no need for TrueCrypt containers at this point. And it's the last level of our challenge. We're going to be doing some other stuff between session 5 and 6, but it's the last level of this particular challenge, I should say. So there aren't a whole lot of protocols in use, so make sure you're familiar with every single one, and read the tips that I provided. All right, and that's about it. I don't see any questions in the chat or anything, so it looks like we're good. All right, gang, so that sums up session 4, and I look forward to session 5. I'll schedule that sometime tomorrow. All right? All right. See you again.